In this video, I will write a sequence. You have to tell me, is this sequence converge or diverge? To find out, we will have to take the limit and then let n goes to infinity. So this one, I will do limit as n approaches to infinity, n to the third power plus 2 divided by phi n. This is a lesson that you studied before that is called limits at infinity. So what we are looking at is the highest degree in the denominator that is equals to 1. So that means I need to divide each term by n raised to the first power. That power determines by the biggest degree in the denominator. If the biggest degree in the denominator is a 6, I will divide each term by n raised to the 6th power. Okay, keep working. So that is equals to limit as n approaches to infinity. You have a n to the third power, okay, plus 2, and then divided by phi n. Divide each term by n, so that is divide each term by n. And then what do I get? I have a limit as n approaches to infinity. I have n squared plus 2 divided by n, and then divided by 5. And then what happens when n goes to infinity? You have a infinity plus 0 divided by 5. That is equals to infinity. So this one you can let n equals to 1, n equals to 2, n equals to 3, n equals to 4, and then you can keep on going to n equals to n, and then you can keep on going until n reach to infinity. And then that infinity tells you that when n becomes really big, these terms, they are pretty much infinity. So that means we say the sequence diverges. All right, so let's do another one. The next one, how about I give you an an equals to 3n squared plus 9 divided by n squared minus 1. Okay, then I will do a limit as n approaches to infinity, and then I will just take this sequence. So I can just duplicate that. And then what's the highest degree in the denominator? The highest degree in the denominator is a 2. This is a second degree. That's the highest degree. And therefore, I have to divide each term by n squared. Divide each term by n squared. And then that is equals to limit as n approaches to infinity. And then you have 3n squared plus 9, and then n squared plus 1. And then divided by n squared, divided by n squared, divided by n squared. So every single term in the sequence divided by n squared. That is equals to limit as n approaches to infinity, 3 plus 9 over n squared. This little fraction will just become a 0. 1 plus 1 over n squared. When n becomes very big, all the little fractions becomes a 0 because 9 or 1 divided by infinity is equals to 0. And then I just make a little mistake right there because I mentioned a minus, but I guess that doesn't change anything. Okay, this one minus, and then this will be a 3 plus 0 divided by 1 minus 0. That is equals to 3 over 1. That is equals to 3. So the limit exists. I can just take this sequence again right there. So this one you have A1, A2, A3, A4 to AN, and then keep on going. When n becomes really large, this time I am going to say those terms, they are approximately equals to 3. And then we can say the series converges. Oh, sorry, I used the wrong word. The sequence converges. Okay, let me just erase that. So I'm going to say the sequence AN converges. I will just picture this as a number that is this value I will just say is a list of number that is either in ascending or descending order. You can just picture a bunch of numbers like that. So if the numbers are in descending order, then their quantity goes up. If the numbers are in descending order, the quantities goes down. So no matter they are going up or they are going down, equals to 3 is either going up or you're going down. Eventually, those value stays around 3. I will just picture that as the graph of a function. So as n goes all the way to infinity, that is approaching to 3. Or you can picture that as a horizontal asymptote. You have a graph of a function. So you graph a function and then you look at when x goes to infinity. So that means you look at the graph, you look all the way to the right hand side, and then you can see as x approaches to infinity, y approaches to 3. So I would consider that as a horizontal asymptote. So when x approaches to infinity, y equals to 3. In terms of a sequence, we say that the sequence converges to 3. All right. Okay, next problem. I have a an equals to 2n divided by this time what if I put the denominator inside a square root? And then this one, I see that the highest degree is a square, right? And then I also know that the square root of n square, that is equals to n. So what I am going to do is, I will do a limit as n approaches to infinity, and then I will just copy this sequence. And then here is the technique that you have to know. I will just divide this term by 1 over, watch, the square root of n square. Since there is a square root right there and then the red has a square root, you can multiply the red n square to the radicand. So the top you only need to divide it by, you also need to divide it by 1 over the square root of n square. And then that is equals to limit as n approaches to infinity. You have 2n divided by, okay, let's put this in red, divided by the square root of n square is equals to n. And then in the denominator, you can bring that inside the radical or the square root, n square, and then plus 1. Now you can say that is divided by n square. This is divided by n square. And then continue. You have limit as n approaches to infinity. The numerator is 2. The denominator, you have a square root 1 plus 1 over n square. So when n approaches to infinity, this little fraction is equals to 0, and then therefore we have a 2 divided by the square root of 1 plus 0, that is equals to 2. So you have a list of values that is either in ascending order or descending order, or you can sketch the graph of this function 2x y equals to 2x divided by the square root of x squared plus 1. You can see when x goes to infinity, y approaches to 2. And then in terms of sequence, we say the sequence an equals to this 2n divided by the square root of n squared plus 1 converges to 2. All right. Okay, I don't want to make this video too long. How about this? I will just stop the video right there, and then in the next video, I will do 3 more examples regarding the series converges or diverges. So if you like the way I explain this, give these videos a like, subscribe to my channel for more contents like that. I will meet you all in the next video.